Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. This is my fourth video in building a tester. So far in the previous videos I've gone over HTML, CSS, and then I tied that into some JavaScript and PHP to access the MySQL. This video is going to be on the Python portion, and we're going to use Python to access the real world. For instance, we'll use it to collect resistance or voltage or the I2C bus if we want a sensor that's that sort of way, because Python is better equipped to access the serial ports and some of the ports on the computer. I'm going to go through where I got my version of Python and how I installed it. And I got it from python.org/downloads. This is the version that I have. I want to note on this install screen, you have this option to add python.exe to the path. And I did that, and that way when you open a command prompt, you'll be able to run Python without having to worry about which directory you're in. And you can see I added the screen where I checked it. And then here's the installation process. And then once you get this set up, the successful dialog, I clicked on this down here, this disable path length limit. I didn't even know there was a path length limit, so I just figured, well, in case this exceeds it, I want to make sure I have access to all of the Python directories. And then once you click on it, it goes away. You can run this command prompt, and I did this just as a test to make sure that it would work. I did reboot the computer after I did the installation. I'm not sure if you needed to or not. I didn't get a pop-up that said, please reboot. Once you type the word Python, it brings it up to these 3 greater than signs, which lets you know you're in the Python editor or prompt. And then just a simple command is print and then hello. If you're not familiar with Python, there are a lot of quick tutorials online that will just step you through some of the simpler things. In my videos, all I'm going to go over is what you need to access data from devices. So this won't be a full-blown Python tutorial. And for me, I am just learning it. I just started learning Python about 3 months ago. So this is also new to me. So we'll be learning together on this. And you can assign a variable. On this one, you don't have to declare what type of variable. So I = 1, print 1, and it prints 1. And it also interprets in the print statement whether it's a string or an integer and automatically converts it. This would be a simple way to run the command prompt and do some tests on some different commands you might want to try for Python. Now for the Visual Studio portion, and that's what I'm using as my IDE, I wanted to add the IntelliSense, so that way it color codes as I type in the script or the code itself for Python. It kind of lets you know if you've got an error or not, and I like that. I went down to my extensions and found this Python IntelliSense, and then I installed it. And then what I did is I went to this directory on my C:\XAMPP htdocs. I added a folder called Python test. And then you can see that I opened that folder in Visual Studio Code. So in that test.py file, I just put this command print hello. And then you can run the code in Visual Studio. If you go up to this run up here, and then you go down to this run without debugging. I've never run it with debugging, so I'm not sure how that would actually work. I've always run it without debugging. And then when you run it, you get this output will say hello. And you get a bunch of stuff that says where it's running, the directories that it's using, and then the output. And so that's a quick way you can test your code and see if you get an error. So that's the steps I went through to set it up and confirm that it works. I ran it in the command prompt just to make sure that I could get some good Python code in there, and then I ran it in Visual Studio. I like the Visual Studio option because while I'm working on the website, I can run it in this mode, and that's part of what we'll be doing. We'll want to know if Python is or isn't running. So JavaScript will sense if it's running or not running. Have to be able to start it and stop it to do some testing on that. Eventually, we'll turn it into an exe and we'll run it. We'll have an icon on the screen for it. But for right now, just to make it simple, we'll run it in this with the run and run without debugging. Now, this is part 4 in the tester. So what I've done is I've copied everything from the last video into this :XAMPP htdocs, and then I'm calling it tester underscore part 4. So that'll be the folder that we'll open. When we're in the browser, it'll be localhost / tester underscore part 4. That's how we'll view it. So don't get confused by that. If you name it something different, if you have a different name in your htdocs for this folder, that's how you'll refer to it. Now I'm going to open this folder in Visual Studio. So this is where we left off. We have our index, our test.js, and our test.php. We're going to add a new folder for Python. And inside that folder, we're going to add this test.py. And just to double check this live, I went ahead and I have x = 1, so we'll take a variable, make it an integer. While x, because x is always going to be 1, so this is always going to run, we're going to print x. So we're just going to print 1 over and over and over and over. And we go up to the run, and we'll run without debugging. And you can see we just get a whole, it's so fast you can't see it, it just fills the screen. But that's what we're getting. And then up here's a little control panel. And this is restart is right here. And stop is right here. Once we stop it, this goes away. Or you can leave it running. And we can alter the code. And in this case, we're going to assign it a string instead. We're going to print it. So now I'd come up here and I'd hit restart. And now it's filled it with cheap controls. So we know that it's functioning fine. Now with Python, you import libraries. So the language itself has some functionality to do what normal languages do. Like it can print strings, it can do math, it can do things such as that. But when you want to do some specialized things, instead of bloating Python with a whole bunch of stuff, you add what it is that you need. And sometimes you'll have to install it. And I use a program called pip. And if you go online, you can figure this out. It's not too complicated. Kind of like I added a XAMPP video. If people do have problems with it, go over to Cheap Controls and fill out that comments over in the help section, and I'll make a video on it. And then install this time. Actually, I don't think you need to install time. That might be part of Python. But this MySQL.connector, you will have to install that. And once we have it imported, then we have to connect to the actual database. And in this case, it's localhost, root, and tester with no password. And it's similar to PHP. But in PHP, we open that file. We open the INI to have some sort of protection so that if someone were to look at this code, the PHP code, they wouldn't see the passwords. And then once we import the passwords, if you go down here, this is where we insert it. So we've got our host, our database name, our user, and the password. Now, I'm assuming we could do something like this with Python, but I don't know how to do that yet. And as I said in a previous video, this particular tester is never going to be on the internet. So I'm not as concerned about security when it comes to the code. What I'm concerned about is security as hackers getting in from the outside. So we're just going to keep this one off the internet. For the Python, if in time I learn how to access the file and I do this, I happen across it, I might change this and append in a future video. But for right now, we're just going to put it in the code. So when we create the connection to the database, we also have to create what they call a cursor. I'm just calling it my cursor. And this my cursor is what's going to hold. It will hold the connection, and it will also hold some of the data that's returned. And when you do the mycursor.execute, you run this command in MySQL. Now this could be a select statement, this could be any statement, but in this case we're going to run show tables. And when we run that command, it's going to store the results in mycursor. And show tables is a command. in this case, we can test this command by going over to phpMyAdmin, selecting our tester database, and just typing it in, and then we'll execute the command. And you can see tables in tester are assemblies and limits. So this is a valid command. There's a command that's in almost every language. It's called for each. If you have a collection of results, you can use this. And sometimes they use the word for each, but in Python it just uses for. So we're just going to use this generic variable x. So for every thing that's returned, for every piece of the collection in my cursor, in this case for each table name, we're gonna step through it. So the first time we'll print the first table name, and then the second time through we'll print the second table name. I'm going to execute this now. And you can see down here we've got assemblies and limits. The other thing in Python that's a little bit different is when you have a loop, like a for or a while loop, instead of putting it in curly brackets, you end this command with a colon. Any commands you want to include in that have to be spaced over the same amount. And in this case, I'm using tab. So if I go back and I hit tab, that's how I'm doing it. If I want another command, like print, so if I add this print test underneath here, it's going to print the table name and then test. We'll run this. You can see it printed the table name test, table name test. And it works because these are spaced the same. But if I go back to here, if I move it back even with the for, it's going to print the two table names, it'll exit the loop, and then it'll print test. You can see it printed the two table names and then the word test. But you can really mess it up by putting a space in here. And you can see that that confuses, I get this red bracket underneath it, or this red curly line underneath it. And it's pointing that I've got a problem there because it doesn't know what to do. So spacing is very important in Python. And even if I add another space, it doesn't know how to treat that either because it treats a tab separate from two spaces. So even though they line up, we still get the error. So you have to be very careful with your spacing. So when I exit the loop, it's expecting to see the next command be even with that for. So that's just something to keep in mind with. If you get an error, it could be the fact that you're using spaces instead of tabs. In some instances, I've run into that a couple times. Now for our example, what we want to do is we want Python to continually update something in MySQL so that we know that Python is running. And then we're going to have PHP tied to JavaScript continue to update that exact same field. So PHP is going to turn it off, and then it's going to check again to see if it got turned on by Python. If it did get turned on, then it's going to know that Python's not running. When we want to do this execute, just like we did in the show tables up here, we have to have a valid MySQL statement. In this case, we're going to update the diagnostics table, and we're going to set pythonactive equal to 1, where ID is 1. Because remember, like is the same as equal to. So we're going to run that command over and over and over and over. Now, this isn't going to run it every second. This is going to run it super duper fast. The other thing in Python is you have to commit it. So just because you put this statement and you execute it, and I'll comment this out later and show you what happens, but it won't do it. You'll check it and it won't actually update it until you run the mydb commit. And I want some feedback in this terminal, so I'm going to print updated. So every time we run this command and commit it, we're going to put down here in the terminal down here, we're going to say updated. And then at the top, I included that time, I imported time. And I'm going to do that to insert a delay. And in the Arduino, it's like using the word delay. It's going to put everything to sleep. It's not asynchronous, so the code will not keep running. The Python script will just stop for 10 seconds. Unlike the Arduino, which is in milliseconds, this is in seconds. So in our case, we're going to execute this command. We're going to commit it to the database. We're going to print a little message, and then we're going to wait 10 seconds. And that way it doesn't flood the terminal down here. If you notice, we're calling a table that doesn't exist because we have assemblies down here and limits. We need to add the table diagnostics. So we're going to add that next. So in the table right now, we have assemblies and limits. We're going to add a new table. We're going to call it diagnostics. I'm just going to add 2 fields. Normally I would add date entered, date deleted, and all that, and maybe some other stuff, and we'll get to that down to the road, because you can add things to tables or modify them later. But in this case, we're going to have ID, and we're going to have pythonactive. The ID is going to be an integer, and we're going to set it to auto increment. And it'll become the primary key. For pythonactive, it's just going to be a 1 or 0. And you can use Boolean for this, but I prefer just to keep it integers. This isn't going to get very large, so I'm not really worried about space. I'm going to default it to inactive, so it'll be a 0. So every time we create a record, we don't actually have to enter anything. When we create it, it's going to set the ID to 1, and it's going to set pythonactive to 0. So I've created this diagnostics table, but I have no records. So we'll insert 1 record, and we don't have to actually add anything. We'll just hit go. And you can see we've got our ID of 1 and pythonactive of 0. And so now when I run this, it should update the table. And you can see now we're seeing assemblies, diagnostics, limits, and updated. And what it should do is in 10 seconds, we should get a second updated, which we did. So it's going to continually update that table and set it to 1. So now if we go back to the MySQL, and you can see where that's 0. If I refresh it, now it's a 1. Now I'm going to go up here and I'm going to comment out this line. Another thing that's different in Python, comments use the pound symbol. So you use pound and then that'll comment out that line. Now we're going to go back to this, to MySQL and change this to a 0. So now we have ID pythonactive 0. And now we'll go back and we'll run this. And you can see it listed the tables and it says updated. So in this case, it should have changed that 0 to a 1. When I refresh it, it stays 0. And that's because we're not committing the update to the database. In PHP, you don't need to do that. It just, the commit is part of it. Something else I'm learning myself, so I'm not sure why that is, but it's just something you have to do. Now I'm going to restart this. And now when we go back, it'll be 1. Once we start this loop, it's going to update this database every 10 seconds, whether we need it or not. So let's say we're not actually using the tester for this period of time. You know, we run it during the day and then we go home. If we leave it on, it's going to keep running and running and running. So this code isn't exactly the efficient code that you might want, but it's a beginning and hopefully it conveys the principles of what I'm trying to say. Now we're going to move over to the JavaScript portion where we're going to check it. And on our tester page, which should be about where we left off, this diagnostics window right here is what we're looking for. We want to be able to change this color to a green. And right now, it should be green because we've set that bit to 1. So in our JavaScript, we currently have this one function that gets the data and displays the limits when we first open the page. So we're going to go below that. And we're going to start another section, and this section will be called Check the Status of Python. So we're going to add this function called check Python, and we'll make it asynchronous and use it as an arrow function. So in other words, this will run, and then other code can continue to run. And this should be pretty similar to the last JavaScript video. We're going to print a little message in the console that says check Python, just so that we know that this is the script we're running or the function that we're running. And then we're going to create a form, kind of a fake form. And up in the last one, we included another one, hello, and then we defined it as world, another key value pair. But in this one, we're only going to put the function check_Python. So that way, when we call this function, we're just going to do the one thing that we need to do. Whereas up here, I had function getLimits, and then I also sent this hello world that we just used to show you something in the console. Then we're going to create this Python response, which is going to return a promise or a fetch to PHP, test.php. We're going to post it, and we're going to include this key value pair up here. I'm hoping to set this up in a way that's fairly repetitive, so that these functions all look similar, but you're just changing maybe one thing. Like in this case, this check Python as compared to up here to this get limits. So it's pretty much the same thing that we up here that we write, and then we'll do something different with the data once we get down here and we get the response. But this beginning should become pretty much the same over and over, and so it should become easy to understand over time. And in this case, we're going to look for the word active. So when we go to PHP, PHP's responsibility is to return the word active if Python is running. So it'll check to see if that bit's set to 1, and if it's set to 1, it'll return active. And it is going to return it in the JSON format. If it is active, we're going to locate this ID of Python indicator on the HTML page, and we're going to set the background color to this 8ACDAE. Now, if we want to verify the color, because it's active, so we would want that to be green, we can go over to our CSS, and at the top of every CSS, I have this color information. And see, this color right here is the green. It ends in DAE, and the red ends in 53A. So the DAE is the green, and the 53A is the red. So if it's active, green. If it's not, red. This Python indicator with the hashtag is an ID. So if I go to index, that should be on there. And you can see in the diagnostics window, I have a span with ID Python indicator. So we're going to change the color of that. Another thing you have to pay attention to is this is not going to run on its own. So we created the function, but it has to be called. So we'll go down to the bottom. Here's where we load the limits. We want to load the limits when we open the page, but we don't want to do it multiple times. But this check Python, we want to do it often. So we're going to set an interval of 5,000 milliseconds. So like the Arduino and unlike Python, JavaScript works in milliseconds. So every 5 seconds, we're going to call that check Python script. So for the JavaScript, that's all there is to that. Now we'll go over to the PHP. Now, and just as I divide up the functions in JavaScript, I also like to do the same thing in PHP. Now we had this else statement down here in case there was no function. I'm going to delete that for now. And we just won't get anything if there's no function. And I'm going to add this check Python title. And just like in JavaScript where I try to keep things fairly similar, I have this if function equal get limits. I'm going to have if function equal check Python. And then a lot of this will be repeated through the next function that I create. And I'm going to initially set my return value to false. Because if it finds that 1, we're going to want to return active. But now I won't have to change it if I don't. It'll just return false. So I should either see false or active. And then I'm going to create my query. So I'm going to use my connection. I'm going to prepare this SQL statement. And once again, this should run if we were to run it in MySQL. So we're going to select pythonactive from diagnostics where pythonactive is equal to 1. So if pythonactive is equal to 1, because we only have one record, it will return a record. If it doesn't find it, if it's set to 0, if Python isn't running and doesn't reset that bit, it'll find no records. So we're going to execute this query next, and then the rows we're going to select, or we're going to fetch all. So once we execute the query, then we have to fetch the results. And then the rows will be returned as an array. So I'm going to count the number of rows in rows. And if it's greater than 0, we're going to change that return value to active. And either way, whether we change it or not, we're going to JSON encode and we're going to return the return value. So we'll either return false or active. But then after we've checked it to see did Python set it to 1, we need to reset it back to 0. So we're going to create another query. In this case, we're going to update diagnostics, and we're going to set Python active equal to 0, where Python active is equal to 1. So if Python doesn't change it to 0, this won't execute, because there won't be a Python that's active that's equal to 1. But that's okay, because if it doesn't, then it's not going to change, and it'll be fine. And then we have to execute that query. And in this case, we were reading from. But in this case, we're writing to. And in Python, remember we had to do that commit. Well, in PHP, you don't have to. Once we execute it, it also takes care of the commit. So that's all we should really need. We have our JavaScript file that is accessing our PHP file, which will get us the results as to whether that bit is a 1 or a 0. If it's a 0, it's going to turn that little display red. If it's a 1, it's going to turn it green. We'll go back and we'll run it now. And notice that I do not have Python running at this time. Now you can see that I'm checking the Python. It's going to put that out every 5 seconds. I don't have Python running, so I'm setting that bit to 0. We can test that by going over here, refreshing it, and you can see that Python active is 0 right now. And if we go over to our network tab, you can see that we have false is being returned every time. So now we'll go back and we'll start up Python. So I've got my test Python. I go to run without debug. And you can see that it says updated down here. I'm going to clear this. And there we go. We've got active. And we're checking, JavaScript is checking every second, or every 5 seconds, and the other one is setting every 10 seconds. So it should toggle between, and you can see that it is. So now if we change our Python to update faster than the JavaScript, we should be in pretty good shape. So I'm going to change this sleep. I'm going to update it every second. And I can leave the JavaScript alone. We'll restart this. And now this is just going to stay. Let me reset this so we can see a couple of. So we got active, and then right after it we got active, and it's going to stay active. In this video, I showed you how to install Python, and then how to do a basic configuration to update one field within a table. By updating that field, it will show that Python is updating the field because we have a JavaScript function that calls PHP that also is updating that same field. So that way we get feedback back and forth. So not only would JavaScript know if Python is updating, but we could do the opposite if we wanted to. Python would know if it ever sees a 0, if it knows that it actually did get a 0, we could have a little indicator on the Python side too. I don't think I'm going to do that because we're hoping that Python runs in the background for this application. Now in the next video, I'm going to collect real-world data using Python. I'm going to show how to connect it to probably an Arduino over a serial port and pull some data in and then show it on the HTML page. I also want to do it through a USB port connected to a Keysight device. But the Keysight devices are really expensive, so I don't know how many people have those. So if you do have one of those and you are wanting to see that, I will get to it. But if I had overwhelming comments, I might get to it first, or I might include it in the next video. I'm not sure how long it'll be adding that portion of it, so I don't know if I'll have to break it up into videos or not. These videos are getting way longer than I thought they would be, and so they don't get the viewership. I know people get bored watching them. And I haven't been very good at putting in timelines. Hopefully I'll get better at that. And maybe I already did on this video. It is the future, so we'll see what happens. Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up. And also consider subscribing to the channel. Thanks for watching.